Hey folks, so in this module we're going to introduce a new sorting algorithm. This one's called merge sort. Based on what we've already seen in previous modules, we've seen stuff like, for example, insertion sort, selection sort, and also another one called shell sort. These are all kind of very, well, I would say they're basic algorithms. They're also algorithms that they're elementary, right? They're straightforward. You can use them, they do the job, but sometimes they're not optimal. So the algorithms we talked about before, let's think about the first one, the selection sort. That one had this runtime of n squared, right? O of n squared. That's, it's something, right? It's not particularly fast. Is there an issue somehow, right? It would be nice if they could sort more quickly than that. And so actually, algorithms like selection sort, typically people don't really, use them, okay? So if you have something that's basically an n squared algorithm for sorting, people typically will shy away from that. And the reason being is we can actually do a little bit better. Now, some of those algorithms, like insertion sort, right, do good at certain scenarios. One we talked about last time is this idea of, hey, if I have a nearly insorted set of data, I can give it to insertion sort and it'll go through it in pretty much O of n time. That's kind of a special case, right? And that's great for insertion sort. But it doesn't solve the general problem, right? So in general, the question is, I have a collection of data, it's all disordered. I want to sort it. What can I do, right? What's going to be the best algorithm, the fastest algorithm for me to handle that? Well, selection sort and insertion sort a little bit slow. They look like O n squared. So we want something a little bit faster. Shell sort is a little bit faster, but again, right, we're not really sure, how it works, right, how fast it is. So probably, right, that's not something we want to use in a production environment. We want something a little bit faster that we do understand. So in practice, right, people basically don't use selection sort and insertion sort. Well, okay, so insertion sort, right, they use a little bit if it's going to be nearly sorted. But these things kind of aren't that common. What's more common is using, two algorithms. One is called quicksort, so that's the one we're indicating here. So this is quicksort, which maybe you may have heard. The other one is merge sort. Both of these are algorithms that act like O of n log n is what they act like, right? And that's significantly better than n squared, right? So instead of quadratic, we have linear logarithmic time. So that's very, very nice, right? I mean, sorting is such a common operation, right? It's useful for so many things. We know we're going to do a lot. We want to do it a lot. So the faster we can get it, the better. So yeah, so what we're going to be talking about in this module is this particular algorithm here. This is called merge sort. We're going to take a little bit of time to go through it. This is going to be kind of for us, we're going to say it's our optimal sorting algorithm, right? Because it can hit this n log n time. And actually later on, we're going to have a discussion on why we think it's optimal, or what makes us think that there isn't a faster way to sort. Because usually when you look at an algorithm like this, your thought is, hey, maybe I can do it better. Maybe I can get log n, right? Because I got from n squared to, well, let's say n times n to n times log n, right? I dropped one of those factors from linear to logarithmic. Why can't I do it again? Why can't I get log n? So we're going to have a little bit of a discussion later on why you can't do that. Something called the sorting lower bound. All right, so we're going to be talking about merge sort here. Merge sort is also, okay, so other than the fact that it's nice and fast, right? It's something we can use in practice. It's also something that it's in common usage, right? So both merge sort and quicksort, right? People actually do use them. One place where you might see merge sort is if you go to Java. I have a link here. It may or not be linkable on the slides you get. But yeah, if you go to the Java API and you go look at arrays and you go see their sorting function to sort an array, it'll say in there, we use merge sort. Actually, there's a little bit more details. This is along the lines of, if the array is really small, if it's like less than 7, use insertion sort, otherwise use merge sort. But somehow, the point is, merge sort is good enough for the Java standard library, right? So it's something that is reliable and is fast, right? Those are two things we want. We want reliable and fast. And so it's definitely something you'll see out in the wild, right? You'll see people that write algorithms and say, oh, sorting is done via merge sort, right? That's something you'll see, in real source code. So yeah, we're going to spend some time talking about merge sort. It's a very nice algorithm. It's very conceptually going to be very clean.